Take a quick second right now and look up at the ceiling above your head. Chances are you're going to spot a small, unassuming little metal fixture peering back at you. We walk under them every single day, in offices, warehouses, apartment buildings, and we completely take for granted the massive, highly pressurized, life-saving infrastructure lurking right behind that drywall. Well, today, we're diving into this high-stakes engineering breakdown. In this explainer, we are going to completely demystify automatic fire sprinkler systems. And we're not just looking at how they miraculously detect fire, but also the intense, gritty, tactical protocols that firefighters use to control them when absolute chaos breaks out. Here is how we're breaking things down today. We'll start with the anatomy of a sprinkler, move on to the types of sprinkler systems, look at the supply and control valves, check out standpipe and hose systems, and finally, wrap up with stopping the water flow.
All right, let's jump right into Section 1, Anatomy of a Sprinkler, the trigger. Now, these systems are universally recognized as the most reliable of all fire protection devices. They rarely ever fail. But dealing with them, it is serious business. If you're a firefighter training to interact with these devices, you literally have to systematically recite this mandatory verbiage before you even begin the task. I am in full PPE. I will let IC, the incident commander, know. I will notify exterior and interior crews. I will work uphill and upwind. I will shut down utilities. You also have to declare that you'll find a second means of egress. This intense life-or-death checklist really sets the stage. So how do they actually trigger? What's genuinely fascinating about the 3 common heat-activated release mechanisms is the sheer mechanical genius of it all. There are absolutely no computer chips here. It is just pure physics. First, we have the fusible link. This holds 2 levers together that cap the water flow. When the heat from a fire reaches a specific temperature, the actual solder holding that link melts, the levers pop, and bam! Water flows. Next, the chemical pellet works pretty much the same way. Solder melts, releasing a plunger. And then there's the frangible bulb. This one is incredibly cool. Heat expands a heat-sensitive liquid inside that tiny glass bulb. The internal pressure violently increases until the bulb physically shatters, completely releasing the valve cap. Now you might be wondering, how do we make sure a sprinkler directly above a blazing industrial oven doesn't go off normally, while one in a heavily air-conditioned office triggers immediately? It's all about temperature ratings. Engineers give these fixed spray nozzles highly specific temperature tolerances, and you can identify them visually in 3 really clever ways. The sprinkler frame arms might be color-coded, the liquid inside that glass frangible bulb will be a very specific color, or, plain and simple, the exact temperature rating is physically stamped right into the metal of the sprinkler itself. And they don't all look or point the same way either. The orientation dictates how the water actually sprays into the room, which is controlled by the deflector attached to the frame. Firefighters are highly trained to spot these visual cues. For an upright sprinkler, which points up toward the ceiling, the deflector creates this nice umbrella shape. For a pendant sprinkler, which hangs down, the deflector has these fanned, larger teeth to push a circular pattern of droplets downward. Then you have sidewall sprinklers that shoot water sideways. You see these a lot in hotel rooms or corridors. And of course, there are flush, concealed, and recessed options. Those just hide the bulk of the hardware above the ceiling plane for aesthetic reasons.
Okay, moving on to Section 2, Types of Sprinkler Systems, the network.
So what exactly is hidden behind those walls and above the ceiling panels? Well, the vast majority of what you'll encounter falls into 2 main categories: wet pipe and dry pipe systems. A wet pipe system is the simplest, and it requires the least maintenance. It literally contains water under pressure at all times. This means the exact second that glass bulb shatters, water is instantly spraying. But here's the catch. It can only be used where temperatures stay above 40 degrees Fahrenheit. If you have a freezing warehouse in the middle of winter, a wet pipe would just freeze solid and burst. And that's exactly where the dry pipe system comes in. Instead of water, it holds pressurized air or nitrogen in the pipes. All these pipes are pitched or sloped to help drain out any moisture. So when a fire activates a sprinkler, the pressurized air escapes first. That pressure drop trips a dry pipe valve, which then finally allows the water to flood into the piping network and out the head. But what if you're trying to protect something extreme, like an aircraft hangar filled with jet fuel? You definitely can't wait for individual little bulbs to pop one by one. You need a deluge system. In a deluge system, there's absolutely no water in the pipes. And get this, all the sprinkler heads are constantly wide open. There are 0 heat sensing elements on them. When external fire detectors sense heat, smoke, or flame, a massive deluge valve opens and water simultaneously blasts out of every single sprinkler in that entire zone. Now, on the complete opposite end of the spectrum is a pre-action system. You'll see these in places like massive server rooms where an accidental water leak would literally ruin millions of dollars of equipment. It uses closed sprinklers and independent fire detection devices. It won't even let a drop of water into the piping network until a separate smoke or heat detector goes off first. Only then is it primed, and even then it still waits for an individual sprinkler head to shatter from the heat before releasing the water. It's an incredible failsafe.
Let's move to Section 3, Supply and Control Valves, the muscle.
So now we cut the network, but where is all this rushing water actually coming from? The anatomy of an automatic sprinkler system is incredibly systematic. Let's trace the journey of the water. It starts down at a municipal water main, pushing its way through a massive control valve. From there, it travels vertically up what's called the riser. That riser feeds horizontal pipes known as cross mains. Those cross mains then branch out further into, you guessed it, branch lines, which finally deliver the water right to the sprinkler heads. Along this whole journey, you're going to find alarm valves, main drains for maintenance, and a massive network of heavy-duty hangers and clamps securely supporting the decreasing pipe sizes all the way to the very end of the line. Now, sometimes the municipal water supply just isn't strong enough on its own to provide the required volume and pressure, especially if a massive multi-story fire breaks out. To make sure pressure is maintained, an electric, diesel, or steam-powered fire pump is incorporated into the system, and it kicks on automatically the second system pressure drops. Also, if you look on the outside walls of commercial buildings, you'll almost always see a fire department connection, or FDC. This is essentially a giant Siamese inlet. A fire department pumper truck can roll up, connect its heavy hoses directly into this FDC, and physically pump extra municipal water and extreme pressure right into the building's own sprinkler system to support it. It's essentially plugging a supercharger right into the building.
So the absolutely crucial point here is control. When firefighters arrive on the scene, they need to know instantly, without a shadow of a doubt, if the building's water supply is open and active or if someone accidentally left it closed. That is exactly why every system is equipped with main water control valves of the indicating type. An indicating valve visibly shows you at a mere glance whether it is open or closed. There are 4 common varieties that fire professionals literally have to memorize.
Let's rapidly decode these visual tells so you can spot them like a trained inspector. First, the OS&Y, which stands for outside stem and yoke. It's super simple. If the threaded stem is visibly sticking out beyond the yoke, the valve is open. If the stem is invisible, it's tightly closed. Next up is the PIV, or post indicator valve. This is a hollow metal post sticking out of the ground with a small glass window that literally displays the words open or shut. You can't miss it. The WPIV is exactly the same concept, but it's a wall post indicator valve sticking horizontally right out of the building's exterior. Finally, the PIVA, or post indicator valve assembly. Instead of words, it uses a circular disc right on top. If the disc is perpendicular to the plate, water is flowing. If it's perfectly in line with the plate, the valve is shut.
All right, on to Section 4, standpipe and hose systems.
Alongside those automatic ceiling sprinklers, large structures require a whole other heavy-duty line of defense. Imagine a massive fire breaks out on the 30th floor of a high-rise. Dragging heavy, water-filled hoses up 30 flights of stairs from a fire truck down on the street? Yeah, that is nearly impossible. Standpipe systems solve this exact problem. They are essentially internal water highways, massive vertical pipes running straight up the stairwells of a building. They provide a means for firefighters to rapidly deploy their hoses and operate heavy fire streams at locations that are incredibly remote from their fire engine outside. It is entirely about expediency and saving vital, life-saving minutes.
Now, these standpipes come in 3 specific classes, and it all boils down to who is actually intended to use them. A Class 1 standpipe provides massive 2.5-inch hose connections. These are strictly for trained fire suppression personnel who are handling large, high-pressure hose lines. Class 2 systems, which are sometimes referred to as house lines, provide a smaller 1.5-inch hose and a nozzle that are actually stored right there on a rack. These are designed for use by either trained building occupants or fire personnel to attack smaller, incipient fires before they spread. And finally, a Class 3 system is the best of both worlds. It combines the features of both, offering the small hose station for occupants alongside that massive 2.5-inch connection for the heavy fire streams used by the pros. And here is what those classes actually look like out in the wild. If you look closely, the Class 1 station is just a heavy-duty, bare metal connection valve just sitting there waiting for a firefighter to hook up a hose. With Class 2, you can see the lightweight single jacket hose pre-connected and neatly folded right there on a rack, completely ready for a trained occupant to grab in an emergency. And a Class 3 setup gives you both of those options sitting right side by side.
Which brings us to our final section, Section 5, Stopping the Water Flow, the Human Element.
So, we've seen how all this pressurized water is delivered, but what happens after the fire is actually out? This is where we enter the action-packed salvage and overhaul phase. A single sprinkler head can pump out massive, flooding amounts of water every single minute. To mitigate property damage, firefighters have to execute a highly methodical procedure to choke off that individual flowing head. Step 1. They absolutely must confirm with the incident commander that the fire is out and it's safe to do so. Step 2. They verbalize the sprinkler orientation. Is it pendant, upright, or sidewall? Step 3. They take physical wooden wedges or a specialized metal tool called sprinkler tongs, and they insert them directly into the sprinkler head, right between the metal arms of the frame. Step 4. They slide the wedges toward each other or clamp the tongs tight. This mechanically blocks the opening, temporarily halting that high-pressure spray. It's hands-on, brute force plumbing.
But here's the gritty reality of salvage operations. Even perfectly placed wedges will still leak. You simply can't just walk away. Firefighters have to immediately manage that residual water to protect the rest of the property. For a small drip, they might simply place a bucket beneath it. If it's a larger, messier leak, they'll construct a catch-all out of heavy tarps. Or they'll set up a water chute to literally redirect the flow down a hallway. But honestly, one of the most ingenious, real-world methods they use is to just take a section of fire hose, hang it directly underneath the leaking sprinkler head, and run the other end straight out of a window or door, acting as a giant makeshift drain pipe.
And that brings us to the absolute golden rule of overhaul operations. You might be thinking, well, why not just run down to the basement and shut off that big OS&Y or PIV control valve we talked about earlier? The rule is, do not touch the main valve until the fire is out. It is absolutely imperative to ensure the fire is 100% extinguished before cutting off the building's water supply. If you shut that valve even a minute too early, a hidden, smoldering fire can violently reignite, and you'll have absolutely zero sprinkler protection left to fight it. When the incident commander finally gives the official order, firefighters will locate the valve. And get this, they are trained that they might even need to bring heavy-duty bolt cutters just to physically chop off the security locks and chains on those main control valves so they can finally shut the entire system down.
It really is an incredible combination of passive, brilliant physics and intense tactical human intervention. We've gone all the way from a tiny, fragile bulb that shatters under heat, traveling through miles of wet and dry pipes, past massive fire pumps, right up to the precise, forceful physical actions a firefighter takes to wedge a sprinkler shut. So I just have to ask, next time you look up at a simple ceiling sprinkler in your office or your apartment building, will you recognize the invisible engineering and high-stakes tactical protocols standing guard over you? Thanks for joining me on this explainer. I really hope you walk away today with a profound new respect for the hidden, high-pressure world of fire safety. Keep looking up and stay curious.